Okay, let's dive into this. Welcome to our latest explainer, where we're going to take a really amazing journey to look at the ultimate big picture. We're totally zooming out from our day-to-day lives to explore Earth's giant space family. We're going to break down exactly what our cosmic neighborhood looks like, who our neighbors actually are, and just how mind-bogglingly massive this whole thing truly is. But hey, before we get way out there, I want to pose a pretty basic question to you. Have you ever just looked up at the night sky and wondered, where does Earth actually live in space? Like, what's our true cosmic home address? It's such a fundamental question, and it really sets the perfect stage for everything we're going to explore today. So let's kick things off with Section 1. Welcome to the neighborhood. You see, Earth doesn't just float randomly in some empty void. It's actually part of a highly structured family. And the invisible glue keeping this entire system from just, drifting off into deep space is gravity. And this brilliantly illustrates exactly that. That formula? It represents the exact physical laws, dictated by mass and distance, that tether all the planets and objects in perfect harmony around the sun. It's literally the anchor of the neighborhood. Which brings us right to Section 2, the center of it all. Because if gravity is keeping everything in check, we absolutely have to talk about the gravitational boss of our neighborhood. Now, what's really interesting about this slide is how it completely shatters our normal perspective. Get this. The sun contains roughly 99.8% of all the mass in the entire solar system. Think about that for a second. Every single planet, moon, and rock, including the actual Earth you're sitting on right now, is crammed into that tiny little 0.2% sliver. The sun just absolutely dominates the whole shebang. 1 million. Just let that massive number sink in for a moment. The sun is a continuous nuclear fusion reactor of such unimaginable immensity that more than 1 million Earths could fit inside it. 1 million. It's honestly a scale that kind of breaks the human brain. But, the sun isn't just huge, it's our ultimate provider. It delivers the light, the heat, and the essential energy required to drive our entire ecosystem. Simply put, without this massive reactor right at the center of it all, life on Earth just flat out wouldn't exist. No way. Moving right along to Section 3, meet the 8 planets. Let's move to our planetary neighbors and see how this builds out. Now that we understand the center, let's shift outward to the distinct worlds sharing our orbit. Starting from the inside, we have Mercury, just baking right closest to the sun, followed by Venus, the absolute hottest planet, then Earth, our beautiful home. Right beyond us is the famous red planet Mars. Then we hit the heavyweights, the gas giants, massive Jupiter, followed by Saturn, famous for those iconic rings, and finally the icy edges, Uranus, which uniquely spins totally on its side, and Neptune, holding down the furthest planetary orbit. Next up, Section 4, comets, asteroids, and more. Because, hey, a neighborhood isn't just the major houses, right? It's everything in between. Our solar system is bustling with literally millions of other objects. We've got moons orbiting the planets, rocky asteroids, icy comets streaking through the dark, dwarf planets, like our old friend Pluto, and vast fields of cosmic dust and ice. It's an incredibly dynamic and busy system out there. Which leads us to Section 5, the mind-boggling scale. Now, I want to completely shift your perspective here to help grasp just how enormous the system really is. So the crucial point is this. If you were to shrink that massive sun down to the size of a standard basketball, Earth wouldn't be a tennis ball or even a golf ball. It would be the size of a tiny peppercorn. And it wouldn't be sitting right next to it either. It would be located several meters away from that basketball. Crazy, right? And the system just keeps going. The outer edge is so unimaginably distant that sunlight, which, remember, is traveling at almost 300,000 kilometers per second, literally the absolute speed limit of the universe, takes many hours just to reach it. That is some serious, mind-blowing distance. Now, to highlight just how beautifully weird our neighborhood gets, let's run through some rapid-fire fun facts. First up, did you know a day on Venus is actually longer than a year on Venus? Yeah, you heard that right. It rotates on its axis so incredibly slowly that it fully orbits the sun before it even completes a single spin. Talk about a long workday. Next up, let's look at our biggest neighbor. Jupiter is so incredibly massive in its own right that you could actually fit more than 1,300 Earths inside of it. 1,300! And what about Saturn's spectacular rings? You might look at them and just assume they're solid bands of rock.
But surprisingly, those iconic rings are mostly just made of chunks of ice reflecting the sunlight. It's literally a giant cosmic ice show.
Finally, let's look way out to the very edge of the system. Neptune isn't just distant and freezing cold, it's wild. It boasts some of the fastest, most extreme winds anywhere in the solar system. The weather out there is absolutely chaotic. So, let's wrap this all up. As we've seen, the solar system is this giant, bustling neighborhood bound together by the immense gravity of the sun. And it's absolutely filled with distinct planets, moons, and cosmic debris. But honestly, the most important takeaway isn't just the abstract science. It's the mind-blowing fact that right now, at this very moment, you are literally riding through this vast space on one of those amazing planets, Earth. Which leaves me with one final thought to really spark your imagination today, based on everything we've just explored. If you had a spaceship and could visit any planet in our solar system, which one would you choose to explore and why? I want you to really think about that as you look up at the night sky tonight. Keep learning, keep looking up, and I will catch you in the next explainer.